Hi everyone! This is the third part of the video where I explain the possibility of using 3D objects as a part of a 2D scene in the Godot engine. It turned out that the previous part was not entirely ideal because I explained the individual parts of the solution using the finished code of our game, which utilizes its own structure of classes and functions. This time, I'm returning to this topic for the last time and will create a puzzle from scratch as an entirely new project in Godot 4. Let's get started. So, as I said, I'm creating a new project which will ensure that there are absolutely no dependencies on any other code in the code I write. Let's do it new and call it, for example, 3D in 2D and fix the project path. Up, where is Godot? Go, here. Great, select current folder and create folder, create and edit. Very well, project is being created and here we go. We will only need three assets: a texture for the background of the scene, a model of a rotating disc, and the sound of a stone scraping against another stone. It will probably be best to create a folder called assets and copy these things into it right away. Okay, right click, create new folder, assets, and I think I have prepared them right here. Yeah, select all and drag them to assets. Cool. So I copy these assets from our game, except for JPEG, which I created in the game as a screenshot to make this project somewhat resemble what you might have seen in the previous part of this series. So I'll start by setting the window size to Full HD, right here in project settings, window, right here, 1920, Namok, sorry. 1920 by 1080. Okay, close. And let's create a new 2D scene right here, to which I will drag this image, chapel JPEG, as a texture to create a new background. And as usual, I'll find it in the inspector and fix the coordinates to 0 and cancel centered, so it's located just like we need it. Very well, let's save the scene using Ctrl S and call it Node 2D. Yeah, sure, why not? Save. Perfect. To simplify each step, I'll set the application to exit with the escape key, which is mapped to the UI cancel action by default. So I'll add a new script to this root node, create it right here, and enter this code. We can delete these two functions and add func unhandled input, into which I will use this code. If input is action just pressed UI cancel, it is here, then we'll simply get out of the game. Quit. That's all. Very well, let's try it out. I will start it and we select the current scene as the main scene. It is here, pressing escape, we are out. Great. Now I'll add the essential elements: a panel that will contain clickable hotspots and a texture with a projection of the disks, and then a SubViewport where we'll define the actual puzzle as a 3D scene. Let's start with the panel. Since it will involve control nodes, the green ones, I'll place them in a canvas layer. So right click and a child node, that would be a canvas layer. Here we go. And as I said, we'll add a panel, which is the control node, panel here. Great. I'll set the size and position of this panel. Let's just find it, show it here. Size and position of this panel according to the values I copied from our game. So it would be just the same. It should be here in layout, transform. So the size is to be 624 by 793, and as for the position, it's 488 by 86. Great. This is where we'll display the 3D scene inside the 2D scene. In the game, we used Sprite 2D, which would be better replaced by a control node, specifically Texture Rect. In this case, I'll do it. Child node and Texture Rect right here. Great. And again, according to I'll set its size and position according to the values from our game. So it would be this 562 by 768, and the position was 33 and 16. Great. Alright, now let's create a SubViewport and model a 3D scene within it that will include 4 disks, a light source and a camera. So again, to the root node, I will add a child node SubViewport, and into which now it doesn't display anything yet because we didn't create a 3D scene. Let's do it. But before I do that, I'll set its size to match the texture rect. So it would be 562 by 768. Cool. Alright, so we'll be adding the 3D elements. Right click, add child node, and it's mesh instance 3D. Okay, this will be the first disk. So it's time to use the model we have in the assets folder. I would like to remind you that this is a model, it's right here, you can see it here. This is a model created in Blender, including the texture we have here, which we painted directly onto the model. Perhaps sometime in the future I'll also make something about 3D modeling, but this time I want to focus primarily on programming. So I will rename this to disk 1 and open it in the inspector. Here it is, and mesh is currently empty. Let's drag this exported model into that. Here we go. It's just a model without a material for now. So I'll switch to, I'm already in the 3D editor, and since the first disk should be the highest on the top, I'll change its y coordinate position to 1.59 meters, I guess. Yeah, it should be right here, 159. Okay, why it's not set? Perhaps 1.59. Great, here it is. I was writing something wrong. Great. And since we want a face with a number to face the camera, which would be right here in this direction, we need to rotate that a bit, and rotation would be exactly 15 degrees. There we go. This is perfect. All right. Now we can proceed with creating a material. Since we only need one material that will be common to all disks, it's best to add it to the geometry section. So let's find material override property, which is here, and create a new standard material 3D. New standard material, click the material, and then I will find the albedo section and drag the dial PNG texture into the texture property, and it's there. Can you see it? Looks great. So we need to change a few more parameters to achieve the same material as we have in the game. These are just visual adjustments that don't affect functionality, so if you don't make them, the scene might not look as nice, but it will still work. Okay, so that would be in shading. I want to disable the ambient light. Now, metallic, let's set metallic to 0.04 and specular 0.32. It basically affects the reflectiveness of the light source, and it has small values because this is supposed to resemble a stone and this is not too reflective. And roughness is related to that as well. Let's set it to 0.37. Now we need this nice bumpiness, which is not there yet, so we will add it in the normal map section. First we need to enable the normal map and then create a texture. And since we don't have any normal map texture, we'll simply simulate that by a noise texture. So I will add new noise texture 2D, click it, and now we want it to be seamless and increase the bump strength to 3.8. Okay, and of course it's supposed to be a normal map, so let's click as normal map. And now we still don't have any noise. Let's do it here in the noise property, new fast noise light. Okay, we have already something there. Let's make it a bit better. Click the fast noise light and change the noise type to cellular and change the frequency to 0.0768. Okay, this is almost the stone we wanted. One last thing, let's open the fractal section and change the fractal type to arranged. Alright, it probably doesn't have too much impact, but that's how we have it in the game, so let's do it the same way. And last thing, I'll add a new script to this disk1 mesh instance 3D node. Okay, click here, create a script which I will call, I think, turn disk, or no, that would be elsewhere. What did I call it? I think disk 3D. Okay, very well, create, and let's keep it empty for the time being, and again save it with Ctrl S. Cool. We are done with the disk 1. Now I will duplicate it 3 times and move each copy along the y-axis. So disk 2, disk 3, disk 4, and now disk 2 will have the y coordinate changed to 106. Disk 3 is, I think, 0.53, and disk 4 should be set to the origin, so it's 0. And we have 4 disks right here. Excellent. We have the scene, and when we return to the texture rect, we can set the texture property to viewport texture and select our subviewport right here. Okay, of course, we won't see anything because we don't have a camera. So let's add a camera 3D to the subviewport. Click here and right click, add child node, camera 3D. Alright, and we need to position it properly. Again, I'll do it just like we have it in our game, and it should be X is 0, Y is 0.798, and Z would be 3.327. Okay, let's click back to the texture rect. Yeah, we already have something, but it seems the disks are smaller than I expected. This is because the camera has too wide of a field of view. Let's change its FOV property to 50 degrees. It is here, 50, and click back. Yeah, perfect. And that's much better right away. Now we need to illuminate the entire scene. I'll add a directional light 3D and adjust its parameters again based on how we did it in the game. So click and add child node, directional light 3D. And I think what we did was to change the color of the light. It was some kind of azure, and the exact code, if I'm not mistaken, is... I cannot edit it, damn it. Ah, now it works. 1284 AB. Yeah, this is exactly the color, and it's too bright, so I think we changed the energy to 0.321. Very well. Let's click back. Yeah, perfect. Scene is complete, and that's left. All that left is to set the transparent background, because we don't want this kind of default background there. So in the SubViewport, I will find transparent BG. Here it is. Click it to on. And we still have the panel here visible a little bit. So let's click the panel and change its background as well. It should be in theme override, styles, and we need a new style box empty. Great. Let's move on to hotspots. So I'll add a reference rect and name it turn left 1. I'll set it to cover the left part of the first disk right here. Let's enlarge it a little bit, and let's do it here in the panel. Okay, so I'll right click the panel, add child node, and it would be reference rect. I'll just select it here. Very well. As I said, I will rename it to turn left 1. And we need to move it to cover this part of the first disk. Let's do it right here, just by dragging and changing the size. It doesn't have to be exact, just roughly cover what we want to click on. This is okay. Very well. And we'll need additional parameters and also a function to be called upon a mouse click. So I'll add a script and name it turn disk GD. Here, click and turn disk GD, create. Very well. And in this script, I'll define variables that will determine which disk this hotspot controls and in which direction it should rotate. So export var disk 3D, and the type is mesh instance 3D, and the second one, export var direction is integer. It will be either 1 or -1. Very well. For now, I won't set them, and instead we'll handle mouse click detection. So in the inspector, I'll just Ctrl S to save it, and in the inspector click to node. Okay, it's not selected. Select the reference rect again, signals, and find GUI input signal. Double click, and now let's make sure that we will create it in the correct script, not node 2D, but this one, turn left. Connect, and we created a callback function. Now we will add this code to this function. So it simply captures all events that happen on this reference rect, meaning including mouse move events, which we don't want, only mouse click and only the left click. So let's do it. If event is input event mouse button, which will filter out the mouse motion, and event button button index is 1, which is the left mouse button, and of course only when the button is pressed. Otherwise it would register also the button release, which we don't want. So if all these conditions are fulfilled, let's call a function on this disk 3D, which we defined here, and the function will be called turn disk with the parameter direction. Okay, the turn disk function doesn't exist yet, but we'll get to it soon. Now, so we don't forget, let's finally set new variables in the inspector. So, select it again, switch back to inspector, and to this 3D I will drag this 3D instance, must be selected, drag it right here, so it's assigned to the first disk, and the direction is 1 to the left. Very well. So I think we don't need this code. We can delete everything and keep only the callback. Okay, so again, Ctrl S to save. And with this script done, let's move on to disk 3D GD, which is defined here for the mesh instance 3D. I'll click it to open it in the editor. And in this script, we need to set the ID of the respective disk, which we'll do using an exported variable again. So export var, let's call it ID, and it would be integer. Very well. I think it's time to implement the rotation of the individual disks and check if we have found the solution of the correct disk positions. In the game, we used a special autoload script that maintained the current state of the game, including the positions of the disks. Here, we'll do it more simply. We'll just define an array variable to hold the expected positions of the disks. Since this variable must be the same in all disk instances, we'll make it static. Other variables are specific to each instance, so those won't be static. Let's do it. So as I said, the first one is static, and call it state. It would be an array of 4 numbers. 1, 2, 3, 4. This is the initial state of the 4 disks. And now the instance variables number, which would be just the current position of this concrete disk, and turning timer and check numbers timer. Basically, the variable turning timer, this one, will ensure that there is a guaranteed delay between individual clicks, and it would be set to 100 milliseconds, I think. And we have check numbers timer for the delay between finding the correct solution and the subsequent action, and it would be, I guess, 1 second. So let's dive into the code. I'll start with the ready function, where I'll perform the initial setup of the disks. So delete the comment, and in the function we need to set the number to its initial state, ID minus 1. Yeah, because IDs would be 1, 2, 3, 4, but the indexes of the arrays are 0, 1, 2, 3. So let's not make a mistake here, and of course we should, where is it? Here, set the ID to 1, just not to forget. This is the first thing, and the second one, we need to set the initial rotation. Rotation on the y-axis would be a result of function get disk rotation. We don't have it yet, so let's implement it. Function right here, func get disk rotation, and we will simply return an angle to rotate to. So it would be the deck to rad, because we need to return a value in radians, but it's easier to calculate with degrees, and it is negative number minus 1 multiplied by 30 degrees, which is simply a rotation from one number to another. And again, let's deduct 15 degrees to face the correct face, just face the camera, sorry. Okay, so this is right. And as I said, this calculation ensures that the disk always rotates toward the camera by the number currently contained in the variable number. It's a simple rotation by multiples of 30 degrees, which corresponds to 12 positions, because 30 times 12 equals 360 degrees, a full circle. Very well. Now to display that, so in the function process, which Godot calls every frame, and which will be responsible for animating the rotation of the disk, we'll insert this line for now. We'll improve it later. So simply we can just copy this and paste it here. Okay. Finally, I'm getting to the implementation of the function called after capturing a mouse click. As we know from the turn disk script right here, the function should be named turn disk and have this parameter direction. So let's do it exactly this way. Func turn disk parameter direction, and now if turning timer is less or equal to 0, let's create a new turning timer. So as I said, 100 milliseconds, so 0.1 seconds, which will be then used in the process function to ensure that we don't just register 2 fast clicks in case of some failing mouse button and this kind of things. Okay, and now let's define a new number as the current number, which would be then increased or decreased by the direction, because the direction will be either 1 or -1. And now we don't want the number to exceed our boundaries. The lowest one is 1 and the highest one is 12. So if new number would be less than 1, we need to rotate the clock to 12. Number is 12. And similarly, if new number is greater than 12, it would be turned to 1. New number is 1. Perfect. And finally, let's call a function that would actually change this number and set it to the state array. And change number, new number. And again, function that does not exist yet, we need to add it. So it's func change number. Let's call number with an underscore, so it won't mess with the variable number. And of course, you can immediately assign it to this mentioned variable. And the second thing we have to do is to add it to the state. id -1 gain is the number. Okay, and now each time we change a number, it's necessary to verify that the current state of all disks equals the expected state, the solution. So it would be here if function is resolved, which is not there yet, but will be. In this case, we will set the second timer, check numbers timer, to 1 second. Okay, and of course we don't want this error here, so I will just create a simple function is resolved, which will be implemented later. Let's make it, colon, return false each time. Very well. Okay, so I think we can try it out right away. I'll run the scene, and by clicking on the top left hotspot, the rotation of the disk will change. But for now, it's an instant change without smooth animation, which we'll fix right away. So let's take a look. And I'm clicking. Can you see how the number changes? Maybe it's too dark, so let me just fix the light. Let's get back to the normal energy and try again. That's better. 1, 2, 3, 4, 5. This is the only active hotspot right now. Nothing else works yet. We'll do it. By the way, you may have noticed that the other disks were not set to their initial values. That's because I forgot to set their IDs right here. Yes, so the second disk should be 2, third disk 3, and the fourth disk 4. Now, if we run it again, we should see 1, 2, 3, 4. 1, 2, 3, 4. Perfect. Very well. So let's fix the movement, which is not smooth right now. We'll do it in the process function. Okay, so first I'll define the target rotation, which is basically the result of the guest disk rotation. And if it's different because the number was changed to another number, we will start rotation. Rotation, which is basically an internal variable of the mesh instance 3D, or more precisely node 3D, which is the superclass for all these classes, and we need only its component y. And now the smooth rotation would be done by linear interpolation of the angle, which is function larp angle from rotation y, the current one, to target rotation, the new one. And now we need to set the weight, which is from 0 to 1. 0 means the initial value, 1 the target value, and anything between it is the transition. And here, as I also mentioned in the previous video, I will make sure that in case of a slow computer and the high delta value, we will never exceed the result, the 1 value. So it would lead to some unpredicted behavior. So minimum of this and 1. Very well. So this is the rotation, and let's not forget to implement the turning timer. To do it right here again with the move toward function, which will simply change the value from the initial to the target, and now there is no weight, there is just a delta value change over time. Okay, let's try it now. Now it's smooth, can you see it? 8, 9, 10, 11, 12, and again 1. Works fine. Great. Now I can go back to the panel and add the remaining 7 hotspots. It will be easy. Using duplication, but I just need to make sure that each node, where is it? Here. Each node has the correct parameter set in the inspector, the disk instance and the direction. So let's do it. Duplicate, Ctrl D, it creates turn left 2, and it's important that it duplicates it along with the attached script and the signal, so we don't have to do it again for all these nodes. And I will simply drag it here, maybe I'll just enlarge a little bit so the rectangles are better visible. Okay, this one should be fine. And again, turn left 3, move it here, and finally turn left 4, this one. Okay, and as I said, don't forget to change it. Direction is still the same, but the disks should be different. So disk 2 belongs to the second hotspot. Did I do it right? Yeah. First disk 1, disk 2. Now turn left 3 is disk 3, and finally turn left 4 is disk 4. Okay, and let's create the other part. Select all of them and Ctrl D to duplicate all of them. I will rename them in a while. Let's just move them to the right side. Okay, perfect. And now This is supposed to be turn right 1, turn right 2, turn right 3, and finally turn right 4. And again, disks are correct, but the direction should be -1. Sorry. -1, -1, and -1. Control S to save. So let's try it again. Run the scene, and now left, right, 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 left, left, right, right. Everything works perfectly. There are two things left: playing a sound when each rotation, with each rotation, and adding a function to detect the correct solution. This will be quite quick. I will simply add a new node to the root node, which would be Audio Stream Manager. Okay, I'll rename it to, for example, turn disk sound, and we need to drag the sound we have prepared here to the stream property. Alright, and now we should find the turn disk script and drag this node with the control key to make a reference. Alright, and we can simply call the function turn disk sound play. Okay, let's try it out. Yeah, sound is playing. Great. Very well. And let's get the solution. So we have the function is resolved. Now it's time to implement it properly, which means we need to compare the current state to the expected state of all 4 disks. Let's do it this way. State 0, the first disk, and let's set the correct solution to 5 on all disks. And state 1 is 5, and state 2 is 5, and state 3 is 5. Alright, and of course we should take some action if the disks are set to the correct positions. In the game, you might remember we opened a secret entrance to the underground. Here, we'll do it more simply. Let's just make the entire panel disappear. So, we need a reference to the panel. Again, I'll drag the node while holding the control key to create a reference. And now, it's time to use the other timer we have here, which means when the solution is correct, the timer was set to 1, so if the timer, check numbers timer, is greater than 0, let's again make a smooth transition using the function move toward from this value to 0, and use delta as the timer, and once it reaches 0, if it's less or equal to 0, and let's make sure that the solution is really correct, so is resolved. In this case, as I said, we'll make the panel disappear. Visible is false. Let's check it out. Okay, so move to 5, first disk, second, third, and 5, and wait for it. It's gone. It works. So, I hope everyone is satisfied this time, and I managed to clarify all the mysteries of this simple yet useful mechanism. In your game, feel free to adjust it as needed, but the basic logic should work universally. So, good luck with your project, take care, and see you in the next video.